this? Well, I know if I were to expand this all out, the leading coefficient would be x cubed, right? Because if I expand this, I'm going to get an x squared as a leading term, and then distributing through that x, I would get an x cubed. So I know the ending behavior for this function is going to look something like coming up like a cube and leaving like a cube. Okay, I know it's not reflected because there's no negative leading coefficient, so I know it looks just like, on the ending behavior, looks just like x cubed, one of our toolkit functions. And then I'm looking at the zeros. I see it's got a 0 at x equals -3. And I also know that it's a double root. It's a multiplicity of 2, so it's going to come up, and it's going to come up like the x cubed function, but then it's going to bounce off the x-axis and turn back around head down. Then someplace here it's going to cross the y-axis, so we could actually certainly figure that out right now. If x equals 0, that's going to be 3 squared and minus 2, so I think that's -18. So I'm going to come down here where about -18 is. Of course, not quite to scale. And then the other root is at x equals 2, and that's just a single root, so that's just going to pass through the function. And we've got to get that ending behavior right, so we knew we kind of had to do something like that. So what I'm seeing is something like this. Comes up, bounces off, goes through the y-axis, then heads up here to infinity. Okay, so let's make a little sketch of that. Bouncing, coming down, heading off. Alright, and that's how you make a sketch of this kind of polynomial.